So yesterday we wrote up the electron configuration and the noble gas notation for iron. So now we need to answer these questions. I need to be able to see the periodic table. So let me get up this sheet here. And I'll rewrite that noble gas or the configuration. Really, to answer these questions, we're going to look at the complete one, so I'll just write out the complete configuration. Maybe. Yep. Okay. So we have 1s2, 2s2, 2p6, 3s2, p6, 4s2, 6. That's what we had, right? So what's that first question ask about iron? How many electron-containing orbitals are there in an atom of iron? So we have to count how many orbitals have at least one electron. So S has how many orbitals? And does it have at least one electron in it? Yes, so I'm going to put a little 1 down here so we can remember there's 1 here. The S has 1. Does it have at least one electron in it? So I'm going to put another 1 down here. P has how many orbitals? And does it have at least one electron in each orbital? Okay, so I'm going to put a little 3 down here so that we can count those. This S has electrons in it. Does this P, all 3 orbitals, have at least one electron in it? How about this S? Does it have at least one electron in it? Yes. Now this D orbital, since this is the last one, we might want to just check it. So let's draw out the D orbital here. If this is our 3D sublevel, and we have 6 electrons, remember we're going to fill 1 at a time and 6. So how many orbitals have at least one electron in it? 5. So all 5 of those. So how many total orbitals have at least one electron? 15. 5. 2. 5, 6, 9, 10, 15. Yep. Oops, what did I hit? What's the next question say? It says, how many of these orbitals are completely filled? All of these are completely filled up until the 3D, correct? Because we have to fill lower energy levels before we can go on to the next energy level. So we know all of the lower energy levels have to be full. Now we need to check this last one. How many of these are completely filled? Just one of them. So if we just take away 4, these 4 are not filled. We'd have 11 orbitals completely filled. And then how many unpaired electrons are there? Again, if these are all full, that means they're all paired. So there's only 4 unpaired. Electrons. And then in which sublevel are these located? They are in which level? Yep, 3D. Yep, in 3D. The 3D sublevel. Questions on how we figured those out? So now we have to do the same thing for zirconium. Does your guys say zirconium? Okay. So zirconium is number 40. So if we need to write out the whole complete electron configuration, we'd start at 1s2 and then what? 2s2. Three D10, yep. Four P6. Yep. So there's the complete electron configuration. We start here, and this is the S block. This is the P block. This is the D block. So we start here, we go 1s, 1, 2. And the next element is 2s, 1, 2. Then 2p, 1, 2, 3, 4, 5, 6. 3s, 2. 3p, 6. 4s, 2. The first D sublevel has to be 3D because the first time we get to D is when n equals 3, S, P, and D. So our D sublevel, first D sublevel has to be 3D. So 4S, 3D, 10. Then we go back up to 4P, 6. Then 5S2. And zirconium's right here, so we're at 4D, 1, 2, and then we stop. Now, what's the noble gas notation? So what's the noble gas that comes before zirconium? Krypton. D2. So basically, what comes after krypton? We'd start at 5s2 and then 4d2. Now do we have how many electron-containing orbitals are there? So I have to go through and count these. These are all full up until the D sublevel. We'll have to check that 4D. So there's 1 here, 3, 1, 3, 1, 5, 3, 1. Now let's check this 4D. We would have just 2 electrons, 2 arrows, 1, 2. So do we have electrons in all 5 orbitals in this case? No. How many orbitals? Just 2. So now we go through an atom. There's 2, 5, 6, 9, 10, 15, 18, 19, 21. Then how many are completely filled? Are any of these D sublevel, 4D sublevels completely filled? No, so we take away those 2. So we'd have 19 orbitals that are full. Why do you start at 1s? 1s is the lowest energy level, and you always have to start way up there at the very first. So we always start at hydrogen on the periodic table. So how many unpaired electrons? 2 unpaired electrons. that should say zirconium. How many unpaired electrons are there in zirconium? How many empty orbitals are there? There's 3 empty orbitals. Good. So the next one, identify the element whose atoms have 2 electrons in the p sublevel of their second main energy level. So the second main energy level means we're in this row, this period, second energy level. And they have to have 2 electrons in the p sublevel. So let's go over to the p sublevel. There's 1, 2 electrons, so that would be carbon. And then what's the total number of electrons in the second main energy level of an atom of this element? So in carbon, how many electrons are in the second main energy level? We have 1, 2, 3, 4 in the second energy level. So those may be called outer shell electrons also, or valence electrons. Now name the element in the third period that has the same number of electrons in its outermost main energy level as this element. So if we're in the third period and we need 4 electrons in the third energy level, that'd be 1, 2, 3, 4. Silicon. Questions on those 3 types of questions? So what element does this noble gas configuration represent? So we have neon, and then 3s2, 3s1, 2 would be magnesium. Okay, this time how many inner shell electrons does it do its atoms contain? So our outer shell electrons are in the third energy level, because that's the highest we get to. So there's 2 on the outside. So anything below that, a couple different ways you could do this. You could count all the way. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or we have 12 electrons on magnesium. 2 of them are outer shell, so just subtract 2 and you'd get 10 also. Because these 2, the third energy level, are the outer shell, and they're asking just for inner shell. So we don't want to count the 2 outer shell electrons. Okay, when we get to the 6th period here, cesium starts the 6th period. We fill in this order. We have 55, 56. These 2 are the S block. Then we get to a D block, which would be 5D. But we go from 57 to 72. So we have to follow 57. It goes to 58 down here. So this is, which block was this? The F block. So now we're going to start F. And just like with the D block, the first F sublevel we get to is when n equals 4, because we had S, P, D, and F. 0, 1, 2, 3, S, P, D, F. So our first F sublevel has to be 4F. Yes, Maddie? This would be in the D block still. Yep. So once we get to 6, we'll do 6S. We'll fill 6S. Then we'll fill this 1, 5D. And then we'll fill the 4F. And then after 71, we go back to 72 and continue filling the 5D sublevel. And then we're back to 6P. Some books may talk about some different ordering. This is how we're going to do it. It's the simple. We'll go through the simple version there. Does it talk about this? Well, in the seventh period, let's look at the seventh period before we do this question. Right here, we'd have 7s, and then what would this start? Which block? Which D? 6D. So this is 7S, 6D, and then we're going to have to jump down to the F block, and this would be 5F all the way over here. And then we'll start here at, we'll finish filling the 6D sublevel, and then there's no 7P. Usually when we get down to this area, you're going to be writing noble gas notations. You won't have to write out the whole thing because they get really long. So here, like mercury, write the noble gas notation for mercury. So what noble gas comes before mercury? Mercury's number 80. Xenon. So we'll write xenon. And then 6s2, 5d1, 4f. If you count across there, we'd have 14, which is the maximum number of electrons we can hold. Okay. And then we'll finish filling the 5d, yep. 9. Yep, exactly 9 because it falls right at the end of the D block. Now, there's a couple ways we can write this, and you may see it a couple different ways. I'll write them down here. We'd have xenon, 6s2, and then add the D's together like this. Or I think your book may write it in order of increasing energy levels, so it would be 4F14 first, 5D10, and then 6S2. Any of those three ways is okay with me, whichever way you want to do it. The whole thing? Oh, the orbital notation? For the D block? You would still just put 5 lines. Mm-hmm.
Why do you go to F if F is down there?
Because right here, it goes from, look at your numbers, it goes from 57 to 72. So we have to fill from 57, go in order to 58, all the way to 71, and then go back to 72. F is down here. These two. Yep. Yep. What's 7, like right down here? Oh, this would be 5F. 5F right here. This is 4F. This is 5F. So noble gas notation for lead. Lead is number 82. So again, our noble gas is xenon. We would have 6s2. Lead is right here. So the noble gas that comes before it is xenon, Pb. And then 5d1 again, 4f14, 5d9, and then we're back into 6p12. So 6p2. And again, you could combine the D levels. You could write it in increasing energy level, whichever you like. So any questions on electron configurations? Right after 57, right here. Why 4 instead of 6 or something? Because remember, F corresponds to the number 3 for L values. And when n equals 4 is the first time we can have n equal or L equal 3. So when n equals 4, meaning 4D. Not anything. Okay, so the last thing is your chapter review. Make sure, well, don't copy these numbers down. Use the one that's on your notes because I changed them a little bit. But that is due at the end of the period Thursday, so we'll have the whole period on Thursday to work on it to turn it in by the end of the period. Your worksheets are due tomorrow, and our quiz tomorrow is just over the atomic, like the quantum numbers, principal quantum number, angular momentum quantum number, magnetic and spin quantum numbers, and then electron configurations also. So just these last couple days that we've done. Okay, you may work with a partner on the worksheet right now.